All right, that was a little Pop Goes the Weasel by Third Base. That's old school. That's back when Mr. Bruss was in high school there, then early 90s. So, what does that have to do with this? Well, we're going to use it to help us memorize the quadratic formula. So we're going to solve quadratics using quadratic formula. Should be pretty awesome. I'm pretty excited about this one. This dude's got a tattoo of it. He's so fired up. There's the formula right there. We're going to use that bad boy to solve some quadratics. So let's get this rolling. Way back when, if I gave you this and said solve it, remember you may think, oh, I wonder if this factors. Can I unmultiply this and solve it? That was one method we could do it. Another method was you could pull up a graph and graph this bad boy and say, hey, there's the graph. Where does it equal 0? So I think I showed you that one this chapter. So we're looking for those roots or these solutions or these zeros. Well, it turns out most things in real life just don't factor. So this doesn't factor. That's just nice. They're nice for math book problems. But if you got a real life applications, the chances of them factoring are pretty slim. So if I don't want to factor, or if it doesn't factor, if I don't have my graphing calculator, I can use this. This works every single time. So it's kind of a nasty formula. Luckily, we've got a little catchy phrase for you. Here it is. Check it out.
Plus or minus the square
Awesome.
root of b squared minus
Awesome.
4ac.
So you can remember it with Pop Goes the Weasel. So let's get back into this A, B, and C and label these parts here. So remember the generic quadratic is ax squared plus bx plus c. So that's our normal quadratic. So, ooh, that's a rough looking A right there. So what is A in this case? It is 3. The coefficient of this x here is 5, and the last one is minus 7. So find your A, B, and C, and this tells you that the x, or the roots, or when it equals 0, is this equation right here. So we're going to say, okay, x equals what? It equals negative b, so that'll be negative 5. Here's our little plus or minus. We did this last section. Remember, we had the positive or the negative version of it. And it's b squared, so that's going to be 5 squared minus 4 times a times c. So be real careful with your signs and everything in here, and all of that is over 2 times a, which is 2 times 3. So half the battle is setting up that monster. Now we just got to simplify it a little bit here. So let's break this down. So it'll be negative 5 plus or minus. I go straight to the calculator on this thing. I'm not going to mess around. I want to know this part under the square root. Later on in Algebra 2 is called the determinant. It determines some things for you. I want to know what that number of the square root is. So, in fact, maybe I didn't even know that. I can type it in just like this. 5 squared minus 4 times a times c, and that is a negative 7. So this is everything underneath the square root, the determinant. Hit enter. Boom, it's 109. So I'm looking at the square root of 109 all over what 2 times 3 is 6. So now this is much cleaner. This is much better. In fact, this is what a lot of people would say is an answer. That's awesome. I just want to make sure you know what that means. What does that really mean, this plus or minus? It means we have two answers. One is when x equals negative 5 plus the square root of 9 over 6, and we've got negative 5. That's a terrible looking. Let me try that again. So we've got negative 5 minus the square root of 109 over 6. So that is these two. That sounds weird. These two answers are the points right here on the graph right here where it crosses where it equals 0. So what if you don't believe me? What if you're like, what in the world? That is a weird looking. This is the exact answer. So this is in simplest radical form. It's exactly right. I've done no rounding. That's super cool. What if I want to get a real life, like who talks like this? Like, oh yeah, obviously the answer is negative 5 plus square root of 109 over 6. Like no one does that. So let's make it a decimal. It's really negative 5 plus the square root of, where's square root? Oh, right here above x squared, 109. And what I do to make sure I'm okay is I hit enter because it's the whole top. So that is the whole top, 5.44, divided by the bottom, and I'm going to get this right here. So technically, really, if I wanted to use this so people could understand me, I would say something like this is 0.91, and it turns out that this on your calculator is 0.91. If I want to do the other one, a nice little trick here is hit second enter. If you hit second enter, it brings back things you were working on. So just go back to what you were working on. And the top is the same except what? This is now minus the square root of 109. Make sure you hit enter because it's the whole top. Divide it by 6 and we get 2.57. So we're looking at 2.57. And I'm thinking maybe that was negative. It was negative. If not, that would have been a bummer. It would have matched our graph. And if you look at this point is negative 2.57. So we are finding the roots again. It's the same thing we've been doing looking at graphs. taking the square root of both sides, but now this formula is going to do it so we don't have to factor or any of that stuff. Super cool. It's a lot of work, but it's really cool. It's the type of thing you can hang on your fridge and be proud, show your parents, be like, oh, look at this. All right. So I want to practice just cleaning these things up. So our answers are going to look like this. I want you to practice putting these in your calculator and getting these as decimals. Remember, it's the whole top divided by that bottom. So it's the whole thing on top divided by bottom. Pause it, try it, see how it goes. All right, so I went ahead and showed the steps in the calculator. Remember, the whole top divided by the bottom. So we're going to round these to the 100th place. So I'm going to round this to, one of my answers would be 6.03. And my other answer would be negative 3.03. So if I break that down to the plus or minus, I get these two answers. Over here, same thing. I just kind of threw a negative b up here. But you should get, again, round this. So I'm going to have to round that up. So it's going to be 0.11. And round that to the 100th. The 7th makes that 6. So we are going to round it to 2 decimals or the 100th place. So make sure you're getting 2 answers on these. So this is where it would be, if you graphed it, we'll be crossing the x-axis. Awesome. How about this? The exact value gets a little trickier. So let's take a look at this and see if we can do it. So here it is. I know I can make that a decimal. What if I want to make it a radical though? I don't want to round it. What do I do here? Well, I need to break down that 98. So if you remember back, Mr. Kelly was hooking us up with these radicals. So what is 98? Remember, you're looking for the biggest number that divides it. I think that'd be 49 times 2. So you get something like this. And why did I pick 49? There are a couple different things that actually give you 98, but I had to pick the 49. Why? Because I know the square root of it. The square root of 49 is 7. So really, it looks something like this. So this is simplified even more. Then if you think about what this actually means, this is a fraction. So this is like saying negative 6 plus 7 over 2, all over 2. And it's like saying negative 6 minus 7 radical 2 over 2. So this is a great answer, but we can actually go farther. It just keeps on going. So what happens here? Well, I can split this fraction up. If you go way old school, one of the first chapters we did is you could split these division fractions. So if I want to split this up, it's negative 6 over 2 plus 7 radical 2 over 2. So I can actually, it's like you're getting that common denominator, you're splitting it up. And this one over here would be the same thing, negative 6 over 2, except now it's going to be a minus 7 radical 2 over 2. Why would I want to do that? Well, check this out. What is 6 divided by 2? It is 3. Does this clean up any? No, it doesn't clean up, so it's still going to be 7 radical 2 over 2. So that's one answer. And over here, you're actually going to get the same thing, negative 3 minus 7 radical 2 over 2. So this is the most simplified way we can write that answer right there. That is both our answers, exactly, no decimal value. That's pretty intense. Let's try another one. What happens with these quadratics also is these numbers get really big in here because I'm squaring things. I've got that 4ac. So again, remember that little trick. I think I showed you this last time. Clear this out. If I'm thinking to myself, okay, I need to break down 832. I know 4 probably goes in there, but I need the biggest number. So remember that little shortcut? I said you could divide it by what? Divide it by x squared. These will be all the perfect squares that go in there. Then go check out your table. So if I look at it, I'm looking for, I know 1 times 832, but this looks like 4 would go in there 208 times. But if I keep going, can I find something bigger? Here's 452. What else? Anything else? There we go. And what's nice about this, remember, that breaks exactly down to 8 radical 13. So what that really means, this is going to be equal to 12 plus or minus, that it's going to turn into 8 radical 13. But what was it? That was the square root of 64 times the square root of 13. That is 832. So notice the calculator told me that right here with this 813. That's pretty awesome. And all of that is over 2. I'm going to leave this one all as one, or I'm sorry, as instead of splitting into 2 fractions, I'm sorry, 2 answers, the plus and the minus. I'm going to go ahead and just split it into my 2 fractions. So I'll say 12 over 2 plus or minus 8 radical 13 over 2. And then what happens here, 12 divided by 2 is 6. And this, sometimes that stays a fraction, no worries. Sometimes it reduces. But check this one out. This one actually reduces here. 2 goes into there 4 times. So in this case, they both kind of reduce. This turns into 4 radical 13. And that's a great answer right there. If you had to split it up, it'd be 6 plus 4 radical 13 is one answer. And you've got 6 minus 4 radical 13. So sometimes that splitting it up helps you out. Sometimes it doesn't reduce at all, but we can split it up and hopefully good things happen. Awesome, very good. And the last one is sometimes you just get awesome answers. So if I'm getting awesome answers, what does that mean? Well, I know the square root of 64, don't I? What number times itself? This is going to be 8. So you've got this. If you want to split the fraction up, you can split the fraction up. In this case, I tend to kind of think about it as saying, okay, 4 plus 8 divided by 4, and 4 minus 8 divided by 4. And why do I do that? Well, I can add these. What is 4 plus 8? 4 plus 8 is 12. And what is 4 minus 8? That's negative 4. Then this one reduces. 12 divided by 4 is 3. And this is negative 1. If you get awesome answers like this that work out friendly, what does that mean? It means you could have factored it. This one definitely would have factored, so if you get cool answers, it's something you could have factored on if you wanted to. But really, you don't have to factor to solve again. How about this one? And the same thing. Actually, try this one. You try to see if you get an awesome answer. All right, hopefully you got this right here. Not quite as nice as this one, but it still works out to 7 halves and negative 17 halves. Those are awesome answers. It could have factored, but those are the solutions for that. Fantastic. So now that we've practiced getting these answers, let's go and put it all together. Can we do it all? I love this. We started off with that one guy tattoo. Are you going to have to remember this formula, or are you going to have to tattoo it to maybe your wrist like this? I think this is Mr. Kelly's. You better check it out. His hand right here so you can remember it. I'm actually going to give this to you on the mastery checks. This is probably one you're going to use so much in math that you're just going to memorize it. If not, you've always got this catchy tune here.
Plus or minus the square root of b squared minus 4.
And let's go ahead and use it to solve this one. So, just like everything else, if I had to, if I was doing it by factoring or graphing, I have to set this equal to 0. So the first thing we're going to do is always set these equal to 0. Whatever you do to one side, you got to do it to the other. So remember, I'm splitting this up. I'm looking at really 12d squared minus 4d minus 23 equals 0. So once I set it equal to 0, then I can go ahead and find my a, b, and c. So I always write this down. I know it can be a little bit tedious here, but I think it's good form to get into this. So you can see, okay, yeah, a is 12, b is negative 4. So there's my 12, there's my 4, and there's my negative 23. And I'm going to go ahead and plug them into this equation over here. So when I plug these things in, I've got negative b. This gets a little weird. B is negative 4. So, okay, now I'm not solving for x. It's whatever your variable is. I'm solving for d. So I've got negative 4. Well, what is negative 4? Remember, that's that change thing, or that's just plus 4. So be careful with that. The negative b is a tricky one. Plus or minus, and this trips people up big time. You have negative 4 squared. So if you're going to use your calculator, you better put that in parentheses. Most common mistake, math teachers will always tell you this right here. This number squared is always positive. Then you're going to subtract your 4ac, so we got our 4, 12, and then our c is negative 23. So there's the inside, or the determinant, and all of that is over 2a, so that'll be 2 times 12. So if I'm solving to get a decimal and a radical, I really like to see what's going on underneath that square root. So let's go ahead and make sure we can do that. So I go ahead, if you're going to do this, if you don't know negative 4 times negative 4 is 16 and you want to type it in, you got to put those parentheses there. The calculator will tell you it's negative 16. It's wrong. It's positive 16. So put that in there. So it's minus 4 times your a times your negative 23. So all of this is underneath the square root. So 1120. So I'm looking at 4 plus or minus the square root of 1120 all over 24. So if I'm going to make that a decimal, I'm going to do it from right here. So I've got that all lined up ready to go. So what am I going to do to decimify that? Is that a word? I don't know if you can decimify it. We are going to do that though. Let's make this a decimal. You've got 4 plus the square root of this. Hit enter, and then I'm going to divide it all by 24. So I'm looking at 1.56 when I round it. So one answer is going to be 1.56. And then my other answer is going to be, I'm going to bring this bad boy back up here. Go back and just change that to an old negative sign. Or I'm sorry, subtraction sign, because I'm going 4 minus. And then I'm going to divide that answer by 24. So I'm looking at negative 1.23. So the decimal is great. The radical, though, it wants both. So I got to break this down into a radical. I definitely am having a hard time off the top of my head thinking, okay, what divides 1120? So I'm going to cheat a little bit and kind of pull this up and look at my table and see if this helps me out. Is there something, not the graph. I'm not too concerned about the graph. Whoa. Okay, there we go. So is there something in here? So yeah, 1 goes in there. A couple things. 4 and 70. Does 70 break down anymore? I don't think it does it? No, I'm not hitting anything. These are all decimals. So 70 is as low as I can go. So again, there it is. So that means this is 16 times 70, but I'm just going to write it straight from here. Well, we'll write out. This really is, because it'd be good to see it. 16 times 70 is 1,120. And again, I'm going to go ahead and say this is 4 plus or minus square root of 16 is 4 over 70 over 24. And then now I'm going to split this fraction up. So I'm looking at, can I slide this bad boy over here? I'm kind of running out of room. I'm going to bring him all the way over here so we can really break this down nice. This equals 4 over 24 plus or minus 4 radical 70 over 24. And then hopefully something cancels. 4 goes into this 6 times, and 4 goes into this 6 times. So I'm looking at 1/6 plus or minus radical 70 over 6. So these answers get kind of crazy when you're doing exact radicals, but that's it. And what happens here, the plus version will equal that, the minus version equals that, and then you've got everything right there. If you get all that, can put that all together, you are money. You are good to go. You're going to blow up this section right here. All right. I want you to try it. I'm going to put the quadratic formula. This is the guy you want to sit behind on the mastery check right here. That's who you want to sit behind. Try these. First one, I want you to do the whole thing. Give me a decimal. Second one, I want you to do the whole thing and give me a radical. Good luck. All right, here we go. So for the first one, I really like to see this. If you can show your work on this, it really helps out for us grading it, and we can give you some better feedback. That I like to see what's under here that you did the square root of 172. Then break it in decimals. We know if you get here, we can help you if you're not getting this. But those should be the answers rounded to 2 decimals. Coming over here, I think this is a little bit trickier here. So it's a lot of plug and chug. Set it up. Break it down to 224, breaks down to 16 and 14. Then it's a matter of simplifying it all the way down to this final answer here. So it's kind of a lot of work here. If you make one little mistake, it throws everything off. But practice this and you should be good to go. Awesome. So there always is going to be a special case. And let's take a look real quick at this special case. You know, I need to set it equal to 0. So I'm going about my business like there's nothing wrong here. And what's going to happen here if I go ahead and find my A, B, and C? So I'm looking at what? A is 2, B is -7, C is 8. So again, everything is fantastic. I've got negative B. Remember that's at 7. I plug in my B squared here. It's -7 squared is positive 49. And I'm going to do, what is my A? 2, and my C is 8. So all of that over 2a. So we got this bad boy. We're good to go. We're getting pretty good at these things. I go ahead to find out what is underneath the square root, and I'm really careful with my parentheses. I'm saying -7 squared not times, minus 4a times c, and I get this -15. Interesting. And all of that is over 4. So it still looks good. But I want to break this down to a decimal. So let's go and break this down to a decimal. What's going to happen here? 7 plus the square root of -15. Can I do that? No, you can't do that. What's wrong with this? You can't take the square root of a negative. It's going to be imaginary answers, something we're not going to mess with until Algebra 2, so we're not going to sweat this. So if you get a negative in the determinant or underneath the square root, if that's negative, what does this mean? It means there's no solution. And remember, graphically, what does a no solution look like? It's kind of like a parabola that never crosses. So it never reaches down here, so it has no solution. So don't freak out if this happens. It's just part of it. It just has no answer. Speaking of other weird ones, how about this? I'm not going to go through and solve it all. Do you see something weird about this one? If you do your A, B, and C, your A is 2. Wait a minute, your C is -5. What is your B? It's 0. So you could do the quadratic formula. You could run it through the big long formula over here if you want to. Or, remember, this is actually last section. I would just say, oh, sure, I'm going to just go ahead and use square roots to solve it. Divide by 2, take square root both sides. So if B is 0, really we're not going to use quadratic formula. It's easier to do this. And then the other little thing that can happen is, let's just pull this guy here. What happens on this case if I do my A, B, and my C on this guy? A is what? A is 5. B is -10, C is 0. Again, so I could do quadratic formula. It works. It's fine. It works every time. I feel great about it. Or this is actually a factoring problem. They both have a 5x in common, and you're left with x minus 2. And look how easy that was. What makes this 0 when x is 2 or 0? That goes back to Mr. Sullivan's lesson here. So easier methods out there, but again, if you want, go quadratic formula. It always works. All right, this is my last one here, and I'm going to end with my favorites. I love the black keys, and this is Deb Spoons doing the black keys. Pretty amazing. Good luck on the mastery check and the test.